Welcome to qnawire.
For this question, we are given that we want a collision, right, using a proton beam to give us available energy that is twice of 38.7 GeV. So we want available energy to be 2 times of 38.7 GeV, which is 77.4 GeV. Because this amount of energy is likely to be greater than the rest energy of a proton. The rest energy of proton is just 938 MeV. So we can use the equation, the square root of 2 times mc squared times the energy of the beam. So this is the unknown that we want to find, given that we want our available energy to be this value. So what we do is we square both sides, and then we divide 2mc squared over. So as mentioned, the mc squared is just 938 MeV. So equals to 0.938 GeV. So it's 77.4 divided by, so we have to square this, divided by 2 times of 0.938 GeV. And this should give us about 3200 GeV. And so this must be the energy of the beam that is hitting the stationary target in order to produce 77.4 GeV of available energy. Now compare this with the colliding beam setup. That is, we have two beams coming in. Now if we have two beams coming in at the same amount of energy, it means that the net momentum of the system is 0. So the available energy would be simply the total energy of each beam, right? So total energy of each beam times 2. And given that we want this total energy to be 77.4 GeV, we can find the energy of each beam, which is just 77.4 divided by 2, which is 38.7 GeV. So definitely it's a much lower value compared to the single beam collider setup.